Hello, this is FlippedHarber for Algebra 2. In this video we'll cover section 4.1, representing data and adding matrices. Our outline for this video, we'll start by talking about what a matrix is, and we'll talk about such things for matrices as dimensions and addresses. We'll look at matrix addition and subtraction, scalar multiple, and properties of matrices. A matrix is basically just a way of storing data. You could look at a matrix as basically a table with all the lines removed. Now, some things to note about the matrix. We generally use a capital letter when naming a matrix. So here we have matrix A, and it's what we refer to as a 2 by 3 matrix, meaning that it has 2 rows and 3 columns. Now that brings me up to a fairly important thing. I want you to remember RC all the time when we're talking about matrices. Everything in matrices is rows, then columns. Rows, then columns. RC, just like the cola, okay? Alright, now, the dimension of a matrix is literally how big it is. It's the number of rows by the number of columns. So the matrix below is read to be a 2 by 3 matrix. A matrix address is where an entry is seen. You can think of it as like a label on a spreadsheet. So matrix A, that's a capital A, has an entry of 16.206 at the address A, that's a lowercase, 2, 1, meaning that it's the second row, first column. Now, adding and subtracting matrices is really easy. The only thing you need to do to make sure is that the matrices are the exact same dimensions. That means the exact same size. Now, I'm not talking almost the same size. I'm not talking close enough to being the same size. They've got to be exactly the same dimensions in order to add or subtract them. If they're the same size, then all you do is add the numbers that are at the same address. So let's take a look at some examples. Here we have 4 matrices: matrix A, matrix B, matrix C, and matrix D. And they ask us to add or subtract if possible. So first they want us to go matrix A plus matrix C. The first thing we should do is even see if it's possible. Matrix A is a 3 by 2 matrix, meaning that it has 3 rows, 2 columns. Matrix C is also a 3 by 2 matrix. So yes, we can do this addition. And all we do is add numbers that are at the same address. Excuse me. Now, C minus A is also possible because A and C are still the same size. Now we just take the numbers in C minus the numbers in A. What about C plus B? B is a 2 by 3 matrix, but C is a 3 by 2. They're close, but they're not the same, so they cannot be added. Alright, let's talk about something called the scalar product. The scalar product is when you put a number multiplying the entire matrix, and really all it means is that you multiply each and every entry in the matrix by the same number. Okay, so let's put the two together. Let's do some matrix products, some scalar products, along with some subtraction. So I want to go 2A, that's the scalar product of 2 times matrix A, minus 3C. Now, we want to do the multiplication first, just like we normally would. So we get the scalar product first, and then we add. Now, here's some properties of equality for matrices. Matrix addition is commutative. That means that if we go A plus B, it's the same as B plus C, provided we can add them. We can associate matrices when we're adding. And there's this thing called the additive identity. It's what is often referred to as the zero matrix. We can make the zero matrix any size we want, any size it needs to be. So it needs to be the same size as the other dimension we're adding it to. And it doesn't change anything, just like adding 0 doesn't change anything. The additive inverse is the matrix that when we add it, we get 0. So the additive inverse creates the additive identity. Okay, so not too bad. Time for you to try some of these on your own. I'll see you in class and I'll see you online.